Hi, I'm Matthew from Sintropia, and I wanted to talk to you about Orma. Orma aims to become your ultimate solution for managing data in Google Apps Script using Google Sheets as a powerful and flexible database. With Orma, you can easily transform your data into objects for intuitive manipulation, thus avoiding complex multidimensional arrays. Its intuitive interface and comprehensive documentation make integration quick and seamless in your projects. Let's start by seeing how it works. In Orma's documentation, get the script ID for installation. Open the script where you want to install Orma. Proceed with the installation by selecting the latest version. In Orma, we talk about databases and tables by emulating the world of relational databases. By database, we mean an instance of the spreadsheet class in Google Apps Script, while by tables, we mean the sheet instance in Google Apps Script. Let's start accessing the database. Orma expands the functionalities of the spreadsheet class. The object obtained via the OpenDB by IDE function is nothing more than an instance of the spreadsheet class enriched with the methods necessary for Orma's operation. Since Google Apps Script does not support autocomplete suggestions for second-level functions of libraries, we have implemented the _info property in the spreadsheet class, such as this will return a detailed JSON listing all the available functions for that specific class in detail and thoroughly. Additionally, since adding properties and methods to existing classes, especially those not managed by us at Google, could cause conflicts, we have taken the precaution of naming all Orma methods and properties with an initial underscore. Now that we have seen how to access a database, let's proceed by accessing the specific tables that are available for this particular database. As we have seen from the _info property, within our databases there is the _getTables function. This function will return an object containing all the available tables, such as various available tables. Please note that for Orma to function correctly, it is very important to note that it is absolutely essential that all tables have an ID field and that the header row is positioned at row 1. Just as the database is indeed an instance of the spreadsheet class, the tables are also an instance of the sheet class. Therefore, within the tables, it will also be possible to identify the _info property, which will show us all the available methods for the tables. Let's start by creating a new instance in the database. Once you have selected the table you want to use, with the _create method, you can create a new record within your table by passing the object containing the properties of the instance you want to store as an argument to the function, such as, for example, to simplify the generation of IDs, Orma offers an _ID function that allows you to generate a unique incremental numeric ID for each table. By passing the argument true into the _ID function specifically, instead of an incremental unique ID, a unique identifier will be generated, a UUID will be returned. This UUID will have the same format as the getUID method of the utilities class in Google Apps Script, but with the generation date concatenated in milliseconds, thus ensuring 100% uniqueness of the generated IDs. Initializing the _create function in a new variable will return the newly created object in the table. But along with its properties, you will find the _save and _delete functions, which are specific and important functions that we will use later to modify and delete records from the tables. The _create method allows you to create a single record at a time, while the _create many method allows you to create multiple records simultaneously. The only difference with the _create method is that you will essentially need to pass an array of objects as an argument instead of a single object, basically. In this case, initializing the function in a variable will return the newly created objects. However, the structure will be slightly different, and we will examine it in detail shortly when we see how to modify and delete elements. For now, let's see how to retrieve data from the tables. The _all method does not accept arguments and will basically return all the records that are present in the table. The _find method, on the other hand, accepts a specific ID as an argument and will return the instance that has the ID matching the one passed into the function. The first by method, however, accepts two arguments. The first is the name of the field, thus the column, within which you want to perform the search, such as email. The second argument is the value to search for example, or like email. This function is designed to specifically return the first record where the value of the specified column matches the value that is passed into the function in the specified column. Additionally, there is a variant of this method called _find_many_by, which will not just return the first record that matches, but will instead return all values in the database that match the search criteria. The _first_by_query method, on the other hand, allows you to search within specific tables for an element, a record, through a query. This method accepts a single parameter, which is the query, and this function will return the first record that satisfies the query request. The query syntax is indeed very simple. In fact, it is basically nothing more than a logical expression written in JavaScript. The only difference with the JavaScript syntax introduced by Orma is that to indicate the object to be examined, you use two curly braces, one open and one closed, which symbolize the object, such as. There is also a version of the _first_by_query function that does not just return the first result that satisfies the query, but all possible results that satisfy the query, and this function is called _find_many_by_query. Now, let's move on to see how to modify instances in the tables. Once we have obtained a single instance through the find, first_by_query, or create method, it will be sufficient to modify the specific desired properties and then call the _save function in order to save the necessary changes. In this way, the database instance will be updated with the requested changes. If you have obtained multiple values using the functions find_many_by, find_many_by_query, all, or create many, you will have the option to choose whether to make the changes in bulk to all the records you have obtained or to a single element. The instances are contained within the data property. By cycling through the instances within the data property, you will have the ability to modify the properties you desire. Afterwards, you can invoke the _save function to propagate the changes within the table to the table in the database. Obviously, in this way, you will have made significant bulk changes to all instances. Alternatively, within the data property, you can access a single instance, such as make modifications to the single instance, and then invoke the _save property for the single instance, like the others, respectively. In this way, changes will be pushed to the database only for the particular selected instance. Now let's see how to delete instances. In addition to the _save function, each instance also has an _delete function. In case the instances were obtained through the functions _find, _force_by, _force_by_query, or create, you just simply need to naturally and essentially invoke the _delete function to easily and effectively delete the record. In case I want to delete instances that have been retrieved from functions such as find_many_by, or from the _find_many_by functions, or from the _find_many_by_query function, or _all, or _create_many, I could choose to delete all the obtained instances in bulk by invoking the _delete function, or by accessing a single instance within the data property and invoking the _delete function to delete a single instance. Furthermore, it is also possible to consider deleting instances individually if necessary. Orma now also includes a hashing function that allows you to save encrypted data in the database. This function requires two parameters, of which only the first one is mandatory, which is the string we want to encrypt. The second argument, however, is indeed optional and is actually the salt. This value is used to be concatenated to the string to be encrypted in order to improve security. This ensures that even two identical passwords are, in a secure manner, indistinguishable and completely once encrypted. Orma is now an open source project designed to grow with its community. Join us and help us improve this tool together. Use it in your projects, share your feedback and suggestions to definitely make it better.